On the 2025 AMC 12A, and this one's a little bit of an easy one for being problem 24. You'd expect it to be hard, but it's not terribly hard. So let's look at this. The circle of radius r is surrounded by 12 circles of radius 1, each externally tangent to the center of circle and sequentially tangent to each other, as shown. And so this basically like flowered looking diagram is what they mean. And so we basically just need to find r, and it has this weird form here. And so since we have 12 circles, what we can do is that's really key because we can just draw in these like lines towards the center of each circle. And I won't be drawing all of them, but just enough to show the point is that if we just draw in all of these, we know that each one of these triangles is congruent because this is 2, this is r plus 1, this is r plus 1, then this is also r plus 1, then this is also going to be 2, and so on and so forth, since all these triangles are going to be congruent. And so what we have is that each one of these central angles is also going to be congruent. So we'll call them theta. So that gives us that since each one of these thetas is going to be the same, we have 12 theta equals 360. So theta is going to equal 30 degrees. And so we basically just have an isosceles triangle here with this is 30 degrees. This is r plus 1. This is r plus 1. This is 2. And we basically just want to find what r plus 1 is. And so this becomes super duper easy because we know this is an isosceles triangle, so we can draw this median, altitude, whatever, because they're all the same in isosceles triangles. We can draw that in here. So this gives us a 15 degrees, since this is also an angle bisector because it's isosceles. And so the actual key figure here, let's just take this one for example, is a right triangle, a 15, 75, 90 right triangle, where these are going to be bisected into 1. So we get a 1, r plus 1, and this side is 15 degrees. And so we basically just want to solve for what r is. So we just basically need to find what sine of 15 is, because sine of 15 degrees is going to equal 1 over r plus 1, because that's just the opposite over hypotenuse. So let's find what sine of 15 degrees is. So it's a really good idea to just have sine of 15 degrees memorized because it's really, really useful, especially in problems like these, but also in other problems as well. So like I would say memorize key things like 15 degrees, 75 degrees, and so multiples of 15 off the like main like 45, well maybe not 45, but like 15 off of 30, and this one is 15 more than 60. And so some things like that, because once you know 15, you can find out 75 and the rest. Maybe even memorize like 54 or 108 or something, because you might see those in pentagons, but I want to say those are super critical. Just memorizing 15 and 75 can save you tons of time. But if you don't have it memorized, you can still derive it. It's going to be painful a little bit, but you could still derive it using the sine half angle formula, where you get sine of alpha is equal to square root of 1 minus cosine 2 alpha over 2. So this half angle formula will tell you what sine of alpha is. Here alpha is 15, and since we know cosine of 30 degrees, we can use this formula to get it, but the derivation is a little bit hairy and like algebraic, so if you just have it memorized, you're saving all the time. You don't even have to think about this formula. So sine of 15 degrees is square root of 6 minus square root of 2 all over 4. Equals 1 over r plus 1, and so now it just becomes a matter of solving. So we get the square root of 6 minus square root of 2 times r plus 1 equals 4. We get r plus 1 equals 4 over square root of 6 minus square root of 2, and so rationalizing the denominator by multiplying by the conjugate here gives us 4 square root of 6 plus 4 square root of 2 all over. What does this denominator become? It becomes 636 minus, and that's a 2, or not 36. That just becomes 6 minus 2. 6 minus 2, which turns out to be 4. So we get, since the denominator is 4 and the numerator is 4, we get r plus 1 equals square root of 6 plus square root of 2. R equals square root of 6 plus square root of 2 minus 1, which is exactly in the form that they ask above. So r is square root of 6 plus square root of 2 minus 1. What is a plus b plus c? It's 6 plus 2 minus 1, since that's c. And so the answer is 7, which is c. So that basically only took, I think, around 2 minutes, and we already solved problem 24, which is supposed to be the second hardest problem on the entire exam. So the key trick here is, try to have these identities, sine 15, sine 75, things like that memorized. If you don't, at least try to memorize the half angle formula because they're really, really useful for problems like these.